So what if you want to measure an angle? What do you end up doing there? Well, we use what's called a protractor, and I think people are probably fairly familiar with the idea of a protractor and angle. I have two different versions here. One is this fabulous $1 item from Staples. It gives us our degrees, and then we have a technical protractor here. And they actually measure in two different ways and kind of two different approaches to how to divide degrees into something smaller. So let's start with the most straightforward example here. So we have this little plastic item, it's clear. We've got this little triangle that I made up. So if you're going to try to measure this angle, and again, measuring angles is one of the hardest things that we do. It's really difficult in a manufacturing setting to try to figure out how to measure a lot of the angles that people draw in on blueprints. Because you don't have access like we have here. I've got a nice flat piece of paper that I'm placing under a clear plastic protractor. That is not usually your case in manufacturing. That said, we had actually taken one of those plastic overhead transparencies, if this generation even knows what they are, and photocopied degrees onto it so we could lay a piece of plastic over manufactured parts. Other than that, you'd have to do this with a coordinate measuring machine. And so angles are surprisingly tricky to try to measure. And a lot of times we try to dimension things on blueprints without using that angular reference if you possibly can, but sometimes it can't be avoided. So when we're trying to measure using this clear protractor here, we're taking the point of our angle and putting it on this little line here, and then lining up the bottom of our triangle so that it's equal with this little 0 mark here. And then we come up and we follow our pink up, and we try to figure out what we have for our angle. So we see here that this is 30 degrees and that's 40 degrees. So that's 35. And then we see here we've got little divisions between here. So this is 35, 36, 37, 38, 39, 40. So these longer lines are individual degrees. And then between those, we have a line separating them. So if we look at this really, really carefully, we're at 35, 36, 37, and not to the halfway point. So we're going to call this 37 degrees. If we were to the halfway point, this would be 37.5 degrees. So that's one approach to dividing out your angles. So the discrimination for the plastic protractor is 1/2 of a degree, so 0.5 degrees. Okay, so there is the cheap plastic protractor version of this. Now this thing here, which is unfortunately a bit rusty, is an industrial protractor, and this takes a different approach to measuring angles. Okay, we're going to take and put our little angle here between our jaws, and this is a little bit tricky to do because normally you'd have something that has some depth to it. This is of course a piece of paper, so you want these two jaws to line up with the edge of your angle. Then you can turn this knob and tighten this down so that you can move this around. All right, so this takes an entirely different approach to how we divide out angles, and it also has a vernier scale. So if we look here, we see we've got a 0 point, and that's the 0 point on our vernier scale. And if we look up to where that is, there's 30, there's 40, so there was 35. And again, just like we saw in the plastic one, we're at like 37. Okay, so we know our angle's about 37 degrees, but what if we needed something more precise? So if we look at our vernier scale here, we see 0, 15, 30, 60, and then the same to the other side. So what do we think those are? Think about, have you ever heard of a degree being divided into minutes? That's the actual technical division for a degree. There are 60 minutes in a degree, and then to divide it out further, there are 60 seconds in a minute. So that's all kind of, funny, and think people are not familiar with that concept. And if we look here between the 0, 15, 30, 45, 60, so what are we seeing? We're seeing increments of 5. And then between each increment of 5, we see 2 lines. So those divided into 3 sections. So what does that tell us about our discrimination of this gauge? Well, we take between 0 and 15, there's 3 sections. So 15 divided by 3 gives us 5. All right, so our discrimination for the mechanical protractor is actually 5 minutes. Now, the real tricky thing about this gauge, and again, this is actually helped by the fact that this is on video rather than live, because you can't see it at all if I'm presenting this in class live, is that you're supposed to use this vernier scale like we did with our other vernier scales and see which lines line up most closely. I dare anybody to see that. And again, this is highly magnified because we're on video here. It's not staying clear, but even if it wasn't, trying to figure out which line lines up most closely is just absolutely maddening. If you could figure it out, if that line happened to be to this side, so clockwise, you would add those minutes. So let's just say that the 15 lined up. We had already said this was 37 degrees, so our measurement there would be 37 degrees, 15 minutes. Okay, if it was to the other side, if you were counterclockwise, you would subtract. So let's say we had the 15 lined up to this side. Well, we wouldn't be at 37 degrees, we'd be at 37 degrees minus 15 minutes, which would actually be 36 degrees, 45 minutes. Again, confusing concept, but I just want you to be aware of these different approaches to measuring and how to divide out degrees and deal with angles. All right, so there is our industrial protractor that has a discrimination of 5 minutes.